In this video, we are learning that how to calculate the pH of a two strong acid. So let us say that one no A is a one strong acid and B is the strong acid. So here from that one, we have to calculate the H plus of the A. We have to calculate how to calculate H plus. First, you have these concentration, whatever the concentration they have given, no, we have to convert it into the normality. So A acid concentration, I am calling it as a N1, and its volume concentration I am calling it as a V1. So N1 plus N1 and V1, this is the H plus concentration of the A. So B is also having the concentration. For example, if they are giving in the molarity converted into normality, so that is called as a N2. So volume is called as a V2. So whatever the concentration, we have to convert it into the normality. This is the H plus concentration of the B. So when we are mixing these together, so final concentration of the H plus will be there. So we have to use this formula. Concentration of the acid A, that is N1, volume of the acid A, that is V1, plus concentration of the acid B, volume of the acid, that is called as a V2 upon the V1 plus V2 we have to calculate. By using this, we will get the H plus ion concentration. Once you got the H plus ion, we can calculate the pH is equal to minus log H plus. By using this formula, we can calculate. So same thing we can calculate it for the base also. Same formula we can calculate. For the base, we can calculate, we will get the OH minus ion concentration. N1 V1 of the base 1, N2 V2 of the base 2 upon the V1 plus V2. From this, once you got we got the OH minus concentrations, you can use this formula. H plus is equal 10 to the power of minus 14 upon the OH minus concentration ion. By using this, you can calculate the pH of the two strong acids. pH very easily you can calculate. So for example, here you can see the one question. Calculate the pH mixtures. They are giving that H2SO4 and HCl. So here now, whenever they are mixing, how to calculate the pH they are asking. So what is our formula? Our formula will be like N final is equal to N1 V1 plus N2 V2 upon the, here now we can total volume we can use. That means this volume and what are the volume. So that's why I am writing here V total. I am writing here. So for example, I am writing that one, no, HCl concentration. So HCl concentration, they have given in the molarity, they have given for example HCl concentration. So HCl concentration, I am calling it as a N1, but they have given the molarity. So how to calculate the normality? Normality is equal molarity into N factor. Here N factor is how much? 1. So molarity is equal to, so which is equal to normality. So N1 is equal to 1 by 100. So V1 is equal to 400 ml. So next one, you can see that one, no, H2SO4 here. So H2SO4 V2 we are calling, his volume is equal to 400 ml. So molarity they have given how much? 1 by 200 they have given, but we want normality. So normality is equal to molarity into N factor. So molarity 1 by 200 into N factor, in the sense number of H plus ions it can replace with H plus ion, or it will give the H plus ion. So it is equal to 2. So whenever it is equal to, so N2 value will be 1 by 100. You can see here, now you can up, so both acid having the normality is equal 1 by 100 only. So now you can apply the formula. N final is equal to N1 V1 plus N2 V2 upon the V total. So N1 we have calculated 1 by 100, and volume V1 is equal to 400, N2 is equal to 1 by 100 into 400. So volume here you can add 400 ml of the HCl, 400 ml of the H2SO4, and 200 ml of the water. So total how much? 8 by the 1000. So this you can write 8 into 10 to the power of minus 3. So this is the H plus ion concentration. So once we got the H plus ion concentration 8 into 10 to the power of minus 3, so apply the pH formula. pH is equal minus log H plus. So here minus log 8 into 10 to the power of minus 3 here. So from this, already we have discussed in the previous video, we can write 3 minus log 8. So here 3 minus log 8 value is equal to 0.9. So pH approximately will calculate 2.1. So like this you can calculate the pH of the any two strong acid as two strong bases of the solution.